Hi there, welcome back to my YouTube channel. In this video, we are making an attempt to solve 100 unique exam questions on algebra. If you are yet to subscribe to my channel, kindly hit that subscribe button and let's go. So the very first question I'm solving is going to be a very simple one. Question 1. It says solve the equation 3x plus 5 is equal to 2x minus 7. How do we solve for x? In 3x plus 5 is equal to 2x minus 7. This is a simple linear algebraic equation. You need to collect like terms, bring all the unknown to the left hand side, and every other term without the unknown, take it to the right hand side. So we have 3x minus 2x is equal to negative 7 minus 5. This is simply x is equal to negative 12. This brings us to the end of the very first question. Let us look at the second question. Question number 2. This is x squared plus 6x plus 9 is equal to 0. This question says solve for x if x squared plus 6x plus 9 is equal to 0. What type of equation is this? This is a quadratic equation, which means unlike the very first one, which we had only one solution, in this case we are going to have two solutions because the power of x in this case is 2. So to begin, we need to find the product of the coefficient here, which happens to be 1, and this constant term, which happens to be 9. So that product is simply 1 times 9. You say product is simply 1 times 9. And then we find the sum. If we have 9 as the product, we are looking for a sum that will give us 6, a sum of the factors of this product that will give us 6 in the middle. You know, we have 1 times 9. 1 times 9 can also be 3 times 3, which if we add 3 plus 3 together will give us 6. That is the sum I'm talking about. Now that we have this sum, we can then go into the given equation and say x squared plus 3x plus 3x plus 9 is equal to 0. We are making an attempt to factorize this equation. So we have x into x plus 3 into x plus 3 is equal to 0. So we have x plus 3 into bracket x plus 3 is equal to 0. What this means is that either x plus 3 is equal to 0 or x plus 3 is equal to 0. Because the two terms in the bracket are exactly the same, it means that we can use just one of them to say x plus 3 is equal to 0 twice, which will imply that x is equal to negative 3 twice. That is the end of the second question in this 100 unique exam series. Let us move on to question number 3. The third question says 2x minus 5 is less than 3x plus 2. What type of equation is this question number 3, and how do we solve for x? First of all, because of the sign in the middle, we can easily tell that this is an inequality, and when solving inequality, you must be careful of one particular rule that says when dividing or multiplying both sides of an inequality by a negative sign, for instance minus 1, you must change the direction of this inequality, which will now be greater than. It is less than, it will now be greater than. If it was less than or equal to, it will now be greater than or equal to. So this question, like we solved the first one, we collect all like terms to the left hand side and every time without the unknown to the right hand side. So we have 2x minus 3x is less than 2 plus 5. This will give us negative x is less than 7. So to solve for x, we need to divide through by -1. And the rule says when we are dividing or multiplying through by a negative number, we must change the sense of this inequality. So this makes this x is greater than -7. And that is the end of question number 3. Let us move on to question number 4. For question 4, we are moving to simplifying simple expressions like 2x squared minus 4x divided by x minus 2. How do you solve or simplify this type of expression? What you need to do in this case is to factorize either the denominator or the numerator, whichever one has factors that can be put in brackets. So as we can see, there is 2 here and 4 is a multiple of 2, which means that we can bring 2 outside of the bracket, and the same thing applies to x, and we will be left with x minus 2 in the bracket this way. So we divide through by the denominator x minus 2, and as we can see, this x minus 2 takes care of this x minus 2, and our final answer for question number 4 is 2x. This is how to simplify algebraic fraction. And without wasting much time, let us move on straight up to question number 5. Question number 5 says, solve the system of simultaneous equations. We have 2x plus 3y is equal to 7. And then we have x minus 2y is equal to 4. There are a few methods available for us to solve simultaneous equations, but for this particular one, we are going to be using both substitution method and elimination method. We can use either of them first. So I'm going to use the elimination method. And as you can see, the coefficient of x in the first equation is 2, while the coefficient of x in the second one is 1. For me to eliminate any of the variables, x or y, I must make sure that the coefficient of such variable are the same. What I mean by this is, if this is 2, then we have to find a way to make the second one also 2. And to do that, I'm going to multiply through by 2, so that this second equation becomes 2x minus 4y is equal to 8. So if I subtract equation 2 from equation 1, this simply gives me 2x minus 2x here is 0. Then I have 3y minus 4y. So that's plus 7y is equal to 7 minus 8 is simply minus 1. That means 7y is equal to minus 1, or we can say divide through by 7, and our y is simply negative 1 over 7. So we have used the elimination method to solve for y. We can now use substitution to solve for x. So in either of the first two equations, we can put this new value that we just got to get the corresponding value of x. I'm going to use this equation here. So I have x minus 2 into my y is minus 1 over 7 is equal to 4. So this is x plus 2 over 7 is equal to 4. Let's take that down here. So we have x plus 2 over 7 is equal to 4. That means x is equal to 4 minus 2 over 7. If I find the LCM here, this is 28 minus 2 over 7, which means that my x is 26 over 7. And 26 over 7 is the same thing as saying 3 whole number, 5 over 7. And that is the end of the fifth question. This is a simultaneous equation, and you can see how we diligently solved it. The next question is question number 6, which says find the domain of the function f of x is equal to 1 over x squared minus 9. To solve this question, we will need to set this denominator not equal to 0. What I mean by that is we have to find every other values of x which are real numbers. They are real numbers and must not make this whole expression equal to 0. So we need to first of all set it equal to 0 and get the value, which is x minus 3x plus 3 using difference of two squares. Or you can simply say this is the same thing as saying x squared is equal to 9, or x is equal to plus or minus the square root of 9, which is plus or minus 3. Or if you are going by this first approach, equals to 0, which means that x minus 3 is equal to 0, or x plus 3 is equal to 0, which will still give us x is equal to 3 or x is equal to minus 3. Either way, we have these two values, and if you put any of those values into x here, you will see that this denominator becomes 0. For instance, let's test with 3. You will simply have 3 squared minus 9, which is 0. If you put negative 3, you still get minus 3 squared, which is 9. Then 9 minus 9 is still 0. So we don't want that to happen. So after getting our value, we then use the interval notation to represent our final answer. By interval notation, it will mean that our final answer is simply all values of x from negative infinity to minus 3, then union minus 3, 3, then union from 3 to positive infinity. This is our final answer. So the value of x is ranging from negative infinity to minus 3, but minus 3 is not included in our solution. Using the number line to denote what I mean, this is minus 3 here, this is plus 3 here. Our value for x is between all values to the left, like that, and all values to the right. The next question is question number 7, and it says find or solve for x given that 4 raised to power x is equal to 64. This is an exponential equation, and we need to apply the law of indices that says that if we have a raised to power m is equal to a raised to power n, therefore m is equal to n. As long as these bases are the same, that is, you have a and then you have a. What I mean by that is if we can find a way to break down 64 into 4 raised to power something, which is 3, and then equate it to 4 raised to power x, we can see clearly that 4 here is 4 here. What this means is that our x is equal to 3. This is how to solve this type of exponential equation. And without wasting much time, let's move on to question number 8. Question number 8 says simplify 2x squared minus 5x plus 3 minus 3x squared plus 2x minus 5. This is algebraic simplification, and what we need to do is to carefully open up the bracket, particularly this one on the right, because of the negative sign in the middle. So what we need to do is to say, write everything in the first bracket as it is, 2x squared minus 5x plus 3, then minus 3x squared, this minus again, multiplied by this plus 2x would give us negative 2x, like that, and then multiplying it with this minus 5 would give us plus 5. That is the backbone of this problem, knowing how to open the brackets with the negative sign given. So I'm going to tidy up my work by collecting like terms. So I have 2x squared here minus 3x squared here, and then I have minus 5x, then minus 2x, then finally I have plus 3 and plus 5. This is going to give me negative x squared, then negative 7x, and then plus 8. Because of the negative signs on x squared and minus x, I can simply rearrange these as 8 minus 7x minus x squared. Remember, it is an expression. We do not have equal to 0 here, so we cannot multiply through by minus to get rid of this negative. We simply leave it as it is because there is no equal to 0. So we just rearrange to make it make sense this way. Moving on to question number 9. Question number 9 says find the slope intercept form of the equation of the line passing through the points negative 2, 3 and 4, minus 1. The slope intercept form equation is written like y minus y1 is equal to m into x minus x1, where the coordinates are already given, which can be y1 and x1. Any of them can be your x1, y1, and m here is your gradient or slope. So we call this gradient. Some call it the slope. It is important to find the slope in this equation to be able to solve or get the complete equation. So let's solve for the slope. The slope is m and is given by the formula y2 minus y1 over x2 minus x1. So like I said, any of them can be your first and second coordinates respectively. So I'm going to use this as my x1, y1 and this as my x2, y2. If I had written it the other way, that is making this my x2, y2 and this x1, y1, I would still arrive at the same answer, but let's just go with the first one. So my m now is going to be equal to y2 is negative 1, then minus y1 is 3, divided by x2 is 4 minus x1 is minus 2. This gives me minus 4 over 4 minus minus 2 is 6. And carefully dividing through here, this is going to give me minus 2 over 3. Now that we have our slope, we can pick, we already know what our x1, y1 is. So we substitute that into this equation and put minus 2 over 32 in place of m here. And this will give us y minus, my y1 is 3, is equal to m is now negative 2 over 3 into x minus x1 is minus 2. So this is what I need to open up to get my complete equation. So this is y minus 3 is equal to negative 2 over 3 into x plus 2. I can multiply through by 3, so that I have 3y minus 9 is equal to negative 2 into x plus 2. I have 3y minus 9 is equal to negative 2x minus 4. So this is 3y is equal to minus 2x. If I take negative 9 to the right hand side, this will simply become plus 5. And this is my final equation. 3y is equal to minus 2x plus 5. Some would prefer it to be in the form y is equal to negative 2 over 3x plus 5 over 3. It is still the same thing. I've only multiplied through by 3. Thank you so much for watching so far. If you are yet to subscribe to my channel, hit that subscribe button, and let's proceed to the next question. The next question we are going to solve for question number 10 says that we should solve the inequality 5 minus 2x is greater than 3x plus 4. So we are back to inequality for this question, and the rule we stated earlier still applies. Let's see if we remember what to do. So we solve this like normal linear inequality by bringing all the unknown to the left hand side. This gives us minus 2x minus 3x is greater than 4 minus 5. With this, we now have minus 5x on the left hand side is greater than minus 1. Now we need to divide by a negative value, which is minus 5. Minus 5. Remember what we said about the sign in the middle when you divide by a negative sign. The sign must change, making our inequality become x is less than 1 over 5. This is our final answer. Let's go straight to question 11. Question 11 says we should factorize x raised to power 3 minus 8. 8 can be written as 2 raised to power 3. And because we have an identity similar to a raised to power 3 minus b raised to power 3, which can be factorized as a minus b into a squared plus ab plus b squared, we can now substitute each of this 2 and x into our new factorized expression. So we say x raised to power 3 minus 2 raised to power 3 is going to be, our a now is x, our b is 2, then into x squared plus, here is going to be a is x and b is 2, so we have 2b or 2x, then plus 2 squared is going to be 4. And that is our final factorized expression. The most important thing I did was to break down this 8 into the form 2 raised to power 3. So we now have our a is x and our b is 2. Just go ahead and substitute that into the whole brackets and you have this. Moving on to question number 12. Question number 12 says we should solve this system of simultaneous equation, which is 3x minus 2y is equal to 5 and 2x plus y is equal to 7. We've also solved a simultaneous equation before. Let's see if we remember the processes involved. We used substitution and elimination earlier, and that is what we are still going to use. So what we need to do is go ahead and multiply the second equation by 2. So we now have 4x plus 2y is equal to 14. The reason I'm doing that is so that it matches up with this 2 right here. If I write it to the new equation, writing the new equation beside each other, I can now solve by eliminating y. To eliminate y, notice that we have negative 2y in the first equation and we have positive 2y in the second equation. Because they are both 2y but only the signs are different, we need to add these two equations together, unlike the first one where we subtracted. To add these two equations, now we say 3x plus 4x, which is going to give us 7x, is now equal to 19. You can see I skipped the entire addition in the middle because that will simply give us 0. So we have 7x is equal to 19, which means that x is 19 over 7. I will not break this down yet. I will just go ahead and substitute this into any of these equations. So I'll use the second equation to solve for y. This will then give me 4 into 19 over 7 plus 2y is equal to 14. I can divide through by 2 so that this gives me 2 here, this gives me 1 here, and this gives me 7. And opening the bracket will give me 38 over 7 plus y is equal to 7. I can solve for y by saying y is equal to 7 minus 38 over 7. Y is 49 minus 38 over 7, which means y is 11 over 7. So for the first one, we got x is 19. X is 19 over 7. And for the second one, we got y is 11 over 7. Both of them can be readjusted to get x is equal to 2 number, 5 over 7. And this to get 1 number, 4 over 7. So that is the end of that question. We now move to question number 13. For question number 13, the question says find the vertex of the parabola y is equal to x squared plus 4x plus 3. Find the vertex of the parabola. I'm going to do this in two ways. The first one is a pretty advanced method and it's actually pretty easy to do. What you need to do is to just differentiate the function y with respect to x. So I'm going to say dy dx, if you're familiar with this approach, is simply 2x plus 4. So you need to set this equal to 0. So when you set dy dx equals to 0, it means that 2x plus 4 is equal to 0, making x equals to 4 over 2, which is minus 4 over 2. So if x is minus 4 over 2, you need to go back and substitute into your actual function. Minus 4 over 2 is simply minus 2. So it means here you now have minus 2 squared plus 4 into minus 2, then plus 3. So whatever this gives you is your corresponding value for y, which is 4 minus 8 plus 3, which is negative 1. So the vertex we are looking for is negative 2 comma negative 1. So that is one way to look at it. Another way to look at it will be to complete the square for the given equation. So we have x squared plus 4x plus 3 equals to y. So this means that if I introduce a bracket for the first two terms in this expression on the right, I am trying to complete the square. So it means that if I have y equals to x squared plus 4x, what needs to be added to x squared plus 4x to make it a perfect square? You are going to use the simple b squared is equals to 4ac. In this case, we are looking for c. Our b is 4, so 4 squared is 16, then 4 times a, which is 1, then times c. So this is 16 is equals to 4c, and our c is simply 4. So I'm going to add 4, and I'm going to subtract 4 at the same time, so that if I put back this bracket, it is as though I have done nothing to the expression. So this is already a perfect square inside this bracket here. And the perfect square is simply x plus 2 squared. So minus 4 plus 3 is simply minus 1. And at the end of the day, the vertex we are looking for is when x plus 2 is equal to 0. When x plus 2 is equal to 0, x is equal to minus 2. And this minus 1 here is the corresponding value of y, making our vertex equal to x equals to minus 2 and y equals to minus 1. And question 14 says that we should solve the equation square root of 3x plus 4 is equal to 7. To solve this, what we need to do is to first square both sides, and doing so, this will take care of this, and we are left with 3x plus 4 is equal to 7 squared is 49. So this is 49, which means that 3x is equal to 49 minus 4. That means 3x is 45. And if you go ahead and divide through by 3, you notice that this 3 takes care of this, and here you are left with 15, which means that our final answer is x equals to 15. This will take us straight to question 15. And question 15, we are asked to simplify 2x squared minus 3x minus 2 divided by x squared minus x minus 2. There is no way anything can cut here until you factorize each of the expressions at the numerator and the denominator. If carefully done, the numerator can be broken into 2x squared minus 4x plus x minus 2, and the denominator can be broken into x squared minus 2x plus x minus 2, so that we can have 2x into x minus 2 plus 1 into x minus 2 at the numerator, and at the denominator we have x into x minus 2 plus 1 into x minus 2, and this would then give us 2x plus 1 into x minus 2 divided by x plus 1 into x minus 2. We can see something common to both products at the numerator and denominator, which is x minus 2. If we divide that through, we will now be left with 2x plus 1 divided by x plus 1, which is our final answer. We'll now move on to question number 16. And question number 16 says, determine the x-intercept of the equation y is equal to 2x squared minus 6x plus 4. This is a bit tricky because the question says find the x-intercept. This is actually another way of simply saying find the root of this quadratic equation, because by finding the x-intercept, you are simply setting y to 0. And when you do that, the equation becomes 0 is equal to 2x squared minus 6x plus 4, or you can write 2x squared is equal to 2x squared minus 6x plus 4 is equal to 0. You can divide through by 2 in this equation, so that the equation becomes x squared minus 3x plus 2 is equal to 0. This is what we now need to solve to get the x-intercept. The product is 1 times 2, which is 2, and the sum is 1 plus 2. This is 3, and we are actually looking for minus 3. So it means that the product needs to be minus 1 times minus 2, and the sum will now be minus 1 minus 2, which is equal to minus 3. The product is plus 3. Therefore, the equation now becomes x squared minus x minus 3x plus 2 is equal to 0. giving us x into bracket x minus 1 minus 1 into, here is 2, not 3. So we have minus 2 into x minus 1 is equal to 0. At the end of the day, we have x minus 2 into x minus 1 is equal to 0. X is either equals to 2 or x is equal to 1. And these are the x-intercepts as required. Moving on to question number 17. Question 17 says, solve the inequality 2 into bracket x minus 3 is greater than or equal to 4x plus 6. To solve this inequality, we need to open the bracket on the left hand side, giving us 2x minus 6 is greater than or equal to 4x plus 6. Collect all like terms to the left hand side, all unknown. So you have 2x minus 4x is greater than or equal to 6 plus 6, which is 12. And this is minus 2x. Remember what we did earlier, simply divide through by minus 2. And when you do that, remember to change the sign to less than. So this takes care of this, and x is less than minus 6. Let's go straight to question number 18. Question number 18 is a new topic and it is on logarithm. The question says, solve for x if log to base 2 of x plus 3 is equal to 5. There are a few rules of logarithm that we need to know, but the major one responsible to the easy solution to this question says that if we have log a base b equals to n, we can change this back to indices as b raised to power n is equal to a. With this simple rule, it simply means that the problem we're given can now be written as 2 raised to power 5 is equal to x plus 3. But 2 raised to power 5 is 32, which means 32 is equal to x plus 3, or x plus 3 is equal to 32. Subtract 3 from both sides gives us x equals to 29. That is a very simple approach, and the major thing is this simple conversion that we did, which is the backbone of this problem. The next question we'll be solving is question 19. And question 19 says we should solve the equation 2 divided by x minus 3 plus 3 divided by x plus 2 is equal to 5 over x squared minus x minus 6. To solve this equation, we'll need to find the LCM of the left hand side. The LCM is going to be the product of the two denominator, which is x minus 3, x plus 2. And here is going to be 2 into x plus 2 plus 3 into x minus 3. And then finally equal to 5 divided by x squared minus x minus 6. With this, we can open up the brackets. So we have 2x plus 4 plus 3x minus 9 divided by, opening the bracket at the denominator will give us x squared minus x minus 6 equal to 5 over x squared minus x minus 6. Because we have the same denominator on both sides of the equation, they can strike out or multiply through by that denominator to get rid of that, so that we now have 2x plus 4 plus 3x minus 9 is equal to 5. 2x plus 3x is 5x. 4 minus 9 is minus 5. Then is equals to 5. So that we can say 5x is equal to 5 plus 5, which is 10. 5x is equal to 10. We can go ahead and divide through by 5. So that x is equal to 5 here is 1 and 5 here is 2. This takes care of this, and x is 2. This is our final answer. Question number 20 said, find the equation of the line parallel to 2x plus 3y is equal to 6 and passing through the points minus 1, 4. Find the equation of the line that is parallel to this given line and passing through this given point. To find the equation of the line parallel to this, we need to make this equation to be of the form y is equal to mx plus c, where m is the slope. So for parallel lines, the slopes are equal. So what we need to do is rearrange the given equation. That's going to be, we have 2x plus 3y is equal to 6, which means 3y is equal to negative 2x plus 6. Divide through by 3. This will give us y is equal to negative 2x over 3 plus 2. So we have our equation and then we have our slope. From here we can clearly see that the slope m1 is equal to negative 2 over 3, which means that m2 is also equal to negative 2 over 3. m2 in this case is the slope of the required equation that we are going to form just now. So we have, for this new equation, y is equal to m2 x then plus c. For us to be able to get the value of c, we will need to substitute every other thing that has been given into the equation. For instance, we now have our m2, which will substitute right into here, and then the coordinate that was given, which is minus 4, x is minus 4, we'll substitute that into here, minus 4, and then minus 1 rather, and y is 4. So we substitute 4 right here. So let's quickly do that to get our corresponding value for c. So this becomes 4 is equal to negative 2 over 3 into x is minus 1, then plus c. So this is 4 is equal to minus times minus is plus, you have 2 over 3 plus c, or c is equal to 4 minus 2 over 3. That means c is 12 minus 2 over 3. So c is 10 over 3. Therefore, our final equation of the parallel line is y equal to m is negative 2 over 3 x then plus 10 over 3. This is the required equation, and our work is done for this problem. Let us now see question 21. Question 21 says, simplify the square root of 18x squared. This is also a new topic in this video. So to simplify this, what we need to do is remember the basic law of sorts that says that if we have the square root of a times b, we can separate this into the square root of a times the square root of b. So if we have 18x squared under the radical, this is the same thing as saying the square root of 18 times x squared, which can be broken down into the square root of 18 times the square root of x squared. For the x squared, this square cancels the square roots, so we are simply left with times x here. And then 18 itself is square root of 9 times 2. So we still need to open up this radical one more time. So we have square root of 9 times the square root of 2, then times x. Square root of 9 is 3, then times root 2, then times x. I'm going to do 3 times x, which is 3x, then times root 2, which will give us 3x root 2. This is our final answer for this question. Let us see question 22. Question 22 says, solve for x if 3 raised to power 2x minus 1 is equal to 27. What we need to do for this question is to express 27 as 3 raised to power something, and that's definitely 3 raised to power 3. So 3 raised to power 3 is equal to 3 raised to power 2x minus 1. And then we remember the law of indices that says if we have a raised to power m is equal to a raised to power n, as long as the bases are the same, the powers must also be equal. So with that in mind, we can clearly see that the bases are the same in this case, therefore the powers must be equal. The powers 2x minus 1 is going to be equal to 3. So I'm going to say therefore 2x minus 1 is equal to 3. And then I'll solve for x here. 2x is going to be 3 plus 1, which is 4. I would then need to divide through by 2 to get my actual value of x. In this case, this takes care of this, so x is equal to 2 here 1, 2 here 2. X is equal to 2, and that is my final answer in this problem. The next question I'm solving is question 23, which says that we should solve for x given that log 2 base 2 of 3x plus 5 is equal to 4. We solved a question very similar to this earlier, so if you did not understand that, this is another opportunity for you to grasp this concept. There is a basic law that we applied in the first question. It says that if we have the logarithm of a base b equal to n, we can change from this log to index form like b raised to power n is equal to a, and vice versa. And since we are already in the logarithm format as given in the question, we need to change to this format, which will now enable us to solve for x. So the given equation, log 3x plus 5 base 2 equals to 4, can now be written as 2 raised to power 4 is equal to 3x plus 5. 2 raised to power 4 is 16, then equal to 3x plus 5, which is also the same thing as 3x plus 5 is equal to 16. Subtract 5 from both sides will give us 3x equals 16 minus 5 is 11. And then divide through by 3. Divide through by 3. So that we have this take care of this. X is equal to 11 over 3, which is 3 whole number, 2 over 3. And this is our final answer for this question. Let us see question 24. Question 24 is going to be on inequality, and this time we have two brackets involved. This is 5 into x minus 2 is less than or equal to 3 into x plus 4. Solve for x. To solve for x, you begin by opening the bracket on both sides. So the first bracket here would be written as 5x minus 10 is less than or equal to. Then we open the second bracket as well, which is 3x plus 12. So let's move all the unknown to the left hand side. We have 5x minus 3x, and then we move every other term to the right hand side. So less than 12 plus 10. 5x minus 3x is 2x, then less than or equal to 22. So we are dividing through by 2. Now you ask yourself, is this a positive or a negative number? Because the number we are dividing with, which is 2, is positive, we do not need to change the direction of this inequality. What do I mean by this? Remember when we said if you are dividing by a negative or a positive number, you must change the direction of the inequality. In this case, because we are not dividing by negative, although we are dividing, but the number is positive, so we keep the direction exactly the way it is. 2 into 22 is 11. And our final answer is simply x is less than or equal to 11. You do not have to change this sign because we are dividing by a positive number. Question number 25. Question 25 says, solve for x given that 4 raised to power x minus 1 is equal to 64. This looks like something we have solved before. If we have, no problem. But if we haven't, what we are expected to do is to simply convert 64 to 4 raised to power 3 and equate it to what we have on the left. And because we have solved something similar, by now we already know that if the bases are the same, then the powers must be equal, meaning that x minus 1 is equal to 3, or x is simply equal to 4. This is our final answer for this question. We would have ended the video here so that it will not get unnecessarily long, but I'm going to solve a few more bonus questions before we come to an end. But if you have questions regarding this topic, kindly use the comment section below and I'll try to treat your questions as quickly as possible. And if you are yet to subscribe to my channel, remember to hit that subscribe button, give this video a thumbs up, and let's enjoy the rest of this video. So this is the first bonus question. I will still proceed with the numbering. This is question 26. This is simplify x squared minus 10x plus 21 divided by x squared minus 49. How do we simplify this? We are expected to factorize the numerator, factorize the denominator, look at what can cancel each other, and then proceed from there. The numerator can be written as x squared minus 7x minus 3x plus 21, while the denominator can be written as x squared minus 7 squared. This is the same thing as saying x into x minus 7 minus 3 into x minus 7, then divided by x minus 7, x plus 7, which will also be written as x minus 3 into x minus 7, then divided by x minus 7 into x plus 7. We can see that this x minus 7 takes out this x minus 7, and we are left with x minus 3 over x plus 7. There is nothing else that can be done to simplify the given fraction. Therefore, our final answer is x minus 3 over x plus 7. Let us see one more question and we call it a video. So we call this question bonus question 27. This question says find the equation of the line perpendicular to 2x minus 3y equals to 4 and passing through the points 1, minus 2. If you remember what we did earlier, we said the approach is to express the given equation of the line in the form y equal to mx plus c, and then the first slope here we will call it m1. The required line, the slope of the required line, we'll call it m2. For the sake of perpendicularity, the product of m1 and m2 must give us minus 1. That is, after getting m1, m2 is going to be negative 1 over m1. So from the given equation above, we have 2x minus 3y is equal to 4. This means that minus 3y is equal to minus 2x plus 4. Divide through by minus 3, minus 3, minus 3. So we get this takes care of this, and we are simply left with y is equal to 2x over 3 minus 4 over 3. As we can see, our slope is simply 2 over 3, which means m1 is equal to 2 over 3. If m1 is equal to 2 over 3, m2 by the calculation earlier is going to be minus 3 over 2. So this is what we now need to put in our second equation, which is the required equation. We have y is equal to negative 3 over 2x plus c. We now need to solve for c. To solve for c, we need to substitute the given point, which is 1, minus 2. So this is x and this is y. So we have minus 2 is equal to minus 3 over 2x, but x is 1, then plus c. Let's make c the subject of the formula. This means we have minus 2 is equal to minus 3 over 2 plus c. C is equal to negative 2 plus 3 over 2. So c is negative 4 plus 3 over 2, which means c is equal to negative 1 over 2. Therefore, the equation of the line is now going to be y is equal to, we got negative 3 over 2 for m, so we have negative 3 over 2x, then minus 1 over 2. This is the required equation perpendicular to the line given in our question, and it is our final answer. Thank you so much for watching. Remember to give this video a thumbs up, subscribe to my channel, and I'll see you soon.